Let's review the operation of multiplying. So when we multiply two numbers together, multiplying is used for repeated addition. So for instance, in this multiplication problem example, I've got 5 times 7 is equal to 35. This problem can also be thought of if I wanted to add a 5 to itself 7 times. So 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. Okay. So that is one of the representations of multiplication, is if I'm repeatedly adding the same number to itself, I can rewrite the operation as a multiplication problem. In a multiplication problem, the two things that I'm multiplying together are called the factors, and the thing that I get out of a multiplication problem, in this case the 35, would be called the product. Now another cool thing about multiplying, kind of like what we saw with adding, is on multiplying 5 times 7 is equal to 7 times 5. This is referred to as the commutative property of multiplication. It says that the order in which you have the two numbers in a multiplication problem does not matter. It just matters who you're multiplying together. The other thing that I've done here very subtly is I've changed around the symbol. There's a couple different symbols that we use for multiplying. So for multiplying, you can use this X representing the times. But then when we get into algebra, it gets really confusing because X is the most common algebraic symbol that we use. So it gets confusing. Is that a multiplication symbol or is that an X for an algebraic variable? So then we start getting into other symbols for multiplying. So we could use the raised dot. So you just need to make sure that it definitely looks raised. It shouldn't be kind of low because then it starts looking like a decimal point. Or another thing that we do is we can use parentheses. So for instance, I can write parentheses just around one of the numbers. So I could, for instance, put the parentheses just around the 7 and have the 5 right next to it. I could put the parentheses around the 5 and have the 7 by itself. Or I could put parentheses around both of the numbers. So this is where multiplying gets maybe a little confusing. Because that one operation is starting to be represented by a couple different symbolic representations. Now, while you may see the X used in various problems, you'll probably see me tend to use the dot when I'm representing multiplying, just because it's been kind of trained for working in various stages of algebra. We just learned to get away from using the X and using the dot instead. So while you may see the X in like problems, and maybe even write them yourself, you'll probably see me tend to use the dot. And that's also getting forward to if your future math careers have you getting toward algebra, it's probably better to start using the dot now. Because you'll need to kind of use it later once we start introducing algebra. All right, and in any case, for multiplying single-digit numbers, it's recommended that you know your multiplication facts through what are called your times 12 tables. So you should know your multiplication facts through 12 times 12. And if you would like some resources about remembering your multiplication facts or learning your multiplication facts or anything like that, I am happy to help. So please reach out and I can share with you some resources. I know that some of the times those facts end up like eluding us, or some of them maybe seem trickier than other ones, but there are ways to whittle it down so you're not memorizing a bunch of them in isolation. There's a lot of connections that can be made among them to make the memorizing process very, very, I'm not going to say easy, but a little bit more manageable. Okay, in any case, I recommend that you know your single-digit multiplication facts, and actually you can see I'm getting through 2-digit here, through the 12 times 12. Okay, so maybe even if you know through your 9, so like 9 times 9, the 10 facts are usually not too terrible because 10 times any single digit number, so for instance like 10 times 7 is 70, and then 10 times 10 is 100. The 11 tables, again, are not too terrible because 11 times any single digit number is that digit repeated. So for instance, like 11 times 5 is 55. Again, so those are not too terrible. And then the 12 facts are maybe a little bit more of a challenge to memorize, but they're important facts to remember, especially in various applications in real life and in the trades and things like that, because things that are multiples of 12 occur quite often. Okay, in any case, let's review how to multiply multi-digit numbers. So in the first example, I have 18 times 358. Now, because of the commutative property of multiplication, I would recommend that when you're setting up a multiplication problem, whatever number has more digits, that number goes on top in your multiplication setup. So even though the 18 occurs first in this problem, I'm going to write the 358 on top, and I'm going to write the 18 underneath. All right, so it's going to help me with place value and positioning as I'm going through the multiplication. All right, so here's where we draw upon our single digit multiplication facts. All right, so here we go. 8 times 8 is 64. I'm going to write down the 4 and carry the 6 into the next column. Now what I'm going to do is I'm going to keep playing this 8 upon each one of the members in the upstairs. So I'm not going to look at that one quite yet. So next thing I'm going to look at is 8 times 5, which is 40. And then plus the 6 is 46. So notice I added the 6 that I carried. I didn't multiply it. So out of the number 8 times 5, which is 40, plus the 6 is 46, I'm going to write down the 6, carry the 4 into the next column. Last multiplication, 8 times 3 is 24, plus the 4 more is 28. So I'm going to record the 28. Now when I go down to the next row right here, or the next row, and I start multiplying by the 1 by each of these numbers right here, I'm going to move over 1 in position. So sometimes it helps to put like maybe an X right here to remind yourself that that position is going to be kind of skipped. So the first multiplication I do here is 1 times 8, which is 8. I'm going to write the 8 right here below the 1. Okay, so this spot is skipped. 1 times 5 is 5, moving over to the left, and then 1 times 3 is 3, again moving over to the left. Now I'm going to add going down, and when I do my adding, remember we start at the rightmost column and move over to the left in case I have to do any carrying into the next column. All right, so I'm going to erase this X right here so you can kind of see that that spot is empty. All right, so right here the 4 just gets carried down. In the next column I have 6 plus 8, which is 14. I'll put down the 4, carry the 1. In this column I'll have 8, 9, and then plus 5 is another 14, so I'll put down the 4 and carry the 1. And this last column I'll have 1 plus 2, which is 3, plus another 3, which is 6. So 358 times 18, or 18 times 358, is 6,444. Now I want to show you a couple different ways to do the multiplication if you want to do the multiplication by hand. Sometimes this algorithm or this method of multiplying, which is called the standard algorithm, is a little confusing for people. So there is another method that I sometimes show, and it's called the lattice method of multiplication. All right, so we're going to put down a series of boxes. Now I have a 3-digit by 2-digit number. So again, whatever the number that has more digits, I like to put that across the top. So that would be 358. And I'm going to make kind of little boxes for those guys. And then along the side would be 18. And I'm going to put that along the right-hand side right here. So 1 and an 8. And then draw another line right there. So you can see I have 3 boxes along the top, 2 boxes along the side, and then 6 boxes total. Through each box we're going to draw a diagonal from the upper right to the lower left. So each box is kind of split into 2 parts. So now I'm going to go through and start multiplying the numbers, and then for the multiplying, if I get something that is only in the 1 spot, I'm going to write a 0 above the line and the number below the line. For an example, 8 times 1 is 8. So I'm going to write that as 0 up here, 8 down here. If when I multiply the 2 numbers together, I get a number that has a number in the 10 spot and the 1 spot, the number in the 10 spot is going to be written above the line. The number in the 1 spot is written below the line. As an example, 8 times 8 is 64. So I'm going to write the 6 above the line and the 4 below the line. I'm going to continue in this manner, filling in all the individual little boxes. So 5 times 1 is 5, so I'm going to write that as 0, 5. 5 times 8 is 40, so I'm going to write the 4 above the diagonal and the 0 below it. Over here, 3 times 1 is 3, so I'm going to write that as 0, 3. And then finally, 3 times 8 is 24, so the 2 gets written above the line and the 4 gets written below the line. Okay, so now the question ends up being, okay, now I filled in all those little tiny boxes. Now what? What do I do with all these little numbers? So this is why this is going to be called the lattice methods. What we're going to be doing is we're going to be starting in the lower right-hand corner, and we're going to be adding along the diagonals, going down, carrying into the next diagonal if needed. So what that means is the 4 doesn't get to be added to anybody, so I'm just going to write it down here. On the next diagonal, I have 8 plus 6 plus 0. So that's 14, so I'm going to write down the 4, and I'm going to carry the 1 into the next lattice. So some people like to write the 1 at the top, other people like to write the 1 at the bottom, whatever. You just have to kind of pick where you want to write it. I like to write it at the top. So then I'll have the 1 that I carried, the 5, the 4, and the 4, right? Because the 0 is not going to affect the sum. So that's going to be 6 plus 4 is 10, plus 4 more is 14. So I'm going to write down the 4, and I'm going to carry the 1. 1 plus 3 plus 2 is 6, and then 0 doesn't have anything there. So then my final answer, I'm just going to read off the numbers that I have written down here, is 6,444, which is the exact same thing we got previously. All right, pretty cool. All right, so I want to show just one more method, kind of using these rectangles or these boxes, which can be referred to as an area model, but this is utilizing that expanded notation, okay, along with what's called an area model. So again, the two numbers that I'm multiplying together are 18 times 358. So 358 can be thought of as 350 and 8. All right, so again, I'm going to make a rectangle, 358. That means that the one side of the rectangle is going to be broken up into 3 pieces. The other number I'm multiplying this by is 18, so 18 can be thought of as 10 plus 8. And you can write that on the left or you can write it on the right, it doesn't matter. I'm going to write it on the left, so 10 and 8. And then that side of the rectangle is going to be broken up into 2 pieces. So then I'm going to have 6 boxes total. Why this is called the area model is each one of these boxes I'm going to multiply the 2 numbers and kind of get just the area for that box. So the reminder, the area of a rectangle is its length times its width. Because these involve a lot of zeros, multiplying with zeros is pretty straightforward. So for instance, 300 times 10, I'm going to have 3 times 1, which is 3, and I'm going to have then 3 zeros after this. All right, 2 zeros from here, 1 zero from here. So 300 times 10 is 3,000. I'm going to play the same game over here in this next box. So 50 times 10. So 5 times 1 is 5, and then I would have 2 zeros after that. 1 zero from here, 1 zero from here. So 50 times 10 is 500. In this next box, it should be 8 times 10, or 80. That fills my first row. Moving down into the next row, I would have 300 times 8. So 3 times 8 is 24, and I would have 2 zeros after that. The next one would be 50 times 8. So 5 times 8 is 40 with 1 zero after that. And then the last box would be 8 times 8, which is 64. So now I just need to add all the numbers in these little boxes. Okay, so then the 3,000 and the 2,400, I'm already looking at those guys, adding them together, so that would be 5,400. What else do I have here? So the 500 and 400 would be 900. the 80 and the 64. So I could put them in the list if you wanted to and add them in columns, but I'm just looking at this. 8 and 6 is 14. So I would have 14 and then the 4 in the ones column. All right, so now I'm going to add these leftover pieces over here after the right. All right, so then in the ones column I would have 4. In the tens column I have a 4. In the hundreds column I would have 14, so I'm going to put down the 4, carry the 1, and then 5 plus 1 is 6. So there's your 6,444. Alright, so again, these numbers you could throw into your calculator and multiply them, but also I think it should just be something where if you're given two numbers that you can quickly throw them down and calculate their product. So let's kind of run through those again because I was showing you 3 different methods of doing this. So let's do this on this other example, the 726 times 142. So I've got 726 times 142 using what is called like the standard algorithm. So first I'm going to multiply 2 by every number on the top, then 4 by every number on the top, then 1 by every number on the top, moving over place values as I go on the different rows. So 2 times 6 is 12. I'll put down the 1, 2, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 7 is 14, so I'll put down the 1 and make sure that 4 is in that column. Right, so in my first row I get 1, 4, 5, 2. When I go to the next number, the 4, and I do 4 times 6, which is 24, I'll have to write the 4 right here. So again, if it helps, you can put like an X right here. I tend to just leave it blank and just remember I have to drop straight down. So 4 times 6 is 24. We'll put down the 4, carry the 2. Now this is where it gets a little bit confusing because I already had a 1 that was hooked there from my prior step. So sometimes I like to put a slash through it just to remind myself I'm not going to look at that anymore. I don't like to erase it or obliterate it because I like to see it as part of my work, but I don't want to get distracted as I move on to my next step. So I just put a little slash through it that says I'm going to ignore that because right now I'm doing 4 times 6, which is 24. I'm putting down the 4, carrying the 2. 4 times 2 is 8, plus the 2 more is 10, so I'll put down the 0, carry the 1. And then 4 times 7 is 28, plus 1 is 29. So my second row is 2904, everybody shifted left 1. Now 1 times 6 is 6, we'll put that straight down below the 1. 1 times 2 is 2, 1 times 7 is 7. So I didn't have any carries on that one, so I didn't have to slash through those because I didn't have anybody distracting me. So now we do column addition going down. So it'll be 2 in the rightmost column, 5 plus 4 is 9. In this column, 4 plus 6 is 10, so I'll put down the 0, carry the 1 into the next column. So I'll have 1 plus 1 plus 9 plus 2, which is 13, carry the 1 to the next column. 1 plus 2 plus 7 is 10. All right, so I like to put my comma in there so we can see how big this is. So this is going to be 103,092 for the final answer. All right, so let's show this using that lattice method. All right, so I'm going to have a rectangle that's 3 by 3 because I have a 3-digit number by a 3-digit number. Let me move this over a little bit. Alright, so I'm going to have 7, 2, 6 along the top, 1, 4, 2 along the side, and then we'll build in the diagonals. Alright, here we go. It doesn't really matter where we start filling in these boxes. I'm just going to start over here, the left and the top. So 6 times 1 is 6. I'm going to write 0, 6. 6 times 4 is 24. 6 times 2 is 12. Moving over, 6 times 1 is 2, so I'll write that as 0, 2. 2 times 4 is 8, write that as 0, 8. 2 times 2 is 4, write that as 0, 4. 7 times 1 is 7, write that as 0, 7. 7 times 4 is 28. 7 times 2 is 14. All right, so now we're going to add down the lattice. So I'll have 2 over here in this lower right-hand box, or triangle, I guess you will. In the next diagonal, I have 4 plus 1 plus 4, which is 9. In the next diagonal, I'll have 6 plus 2, which is 8, plus another 8, which is 16, plus 4, which is 20. So I'll put down the 0, carry the 2 into the next lattice. So I'll have 2 plus 2, which is 4, plus 8, which is 12, plus 1, which is 13. I'll put down the 3, carry the 1. And then I'll have 1 plus 7 plus 2, which is 10. I'll put down the 0, carry the 1, and then 1 plus 0 is 1. So my final answer, reading down the left and the bottom, would be 103092, or 103,092. Finally, showing that expanded form with the area model. All right, so we'll have 726 along the top, and then 142 along the side. All right, so we have 9 boxes to fill. So here we go. First box on the upper left, 7 times 1, which is 7. And then I'm going to have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. The 20 times 100, so the 2 times 1 is 2, followed by 3 zeros. 6 times 100, so I'm going to do 6 times 1, which is 6, followed by 2 zeros. That completes my top row. Next row down. 700 times 40, so 7 times 4 is 28, followed by 1, 2, 3 zeros. 20 times 40, 2 times 4 is 8, followed by 2 zeros. 6 times 40, 6 times 4 is 24, followed by 1 zero. That completes my next row. Then moving down, 700 times 2, so 7 times 2, which is 14, followed by 2 zeros. 20 times 2, 2 times 2 is 4, followed by 1 zero, and then 6 times 2 is 12. Now, you could grab all these numbers and just go ahead and start putting them in your column addition and adding them going down, but I like to group them just to kind of save myself from how many numbers are in my column, because when those columns get a little long, they can also make you a little cross-eyed. All right, so looking at these, this 70,000 and this 28,000, if I put those guys together, so I'm looking at these two, putting them together, 70 and 28 is 98, and then I'll have 1,000. All right, so looking at other numbers, this 800 and 1600, 8 plus 6 is 1400, plus this other 1400 right here would be 2800. So I can put maybe that in my list, 2800. I've got this 2000 right here. I'll put that on my list. The 240 and the other 40 is 280. And then I have that 12. Okay. All right, so the whole point is to make this easy. So if you're having problems kind of putting some of these numbers together and things like that, you can just go ahead and put them in your list. But the whole point is the more you interact with these by hand calculations, the more flexible you get at them, the faster you get at them, and the more comfortable you get with the various processes. All right, so again, we're going to just add going down. In this rightmost column is just the 2. Right here is 8 plus 1, which is 9. In the next column over, I'll have 8 plus 2, which is 10. I'll put down the 0, carry the 1. And the next column I'll have 8, 9, 10, 11, 12, 13. I'll put down the 3, carry the 1, and then 9 plus 1 is 10. Okay. So same answer, slightly different method. Multiplication involves a lot of steps. And it's also a very common operation that is used. So that is why there is a couple different representations I wanted to show you about how to compute it.